Hi everyone. It's a pleasure to be here. We're going to start by, we're going to talk about a joint project that we've been working on together with Bruno for a while. But maybe before starting, we should maybe introduce ourselves so that you know who is who. And I should point out that we've decided to give the talk at the same time in order to save time. So that's why anyways. Bruno, maybe you want to say a few words about who you are?
So my name is Bruno Teheux. I'm an assistant professor at the University of Luxembourg. My research topic is mathematical logic. But I also do a lot of outreach activities, and so we meet people, and we try to. I collaborate a lot with Hugo, and we try to do math in a very different way with them, to make it short.
Absolutely. So I'm Hugo Parlier. I'm a professor at the University of Fribourg in Switzerland. This is very recent. This is 10 days old, and so I work in geometry and topology. As a researcher, and like Bruno, of course, and with Bruno, we're very interested in doing outreach, which is sort of it's very different from what we're doing here, which is more a very formal intellectual discussion. And so which is not outreach, I suppose it is a form of outreach. So in fact, while we do this, because Bruno and I, we'll talk more about this, is more math in practice and have people do things, I'm going to pass around an iPad. And while we talk, please make drawings on this iPad. And so the only rule is that you draw from left to right. And please go ahead.
And in the meantime, you can try to decide who is Hugo and who is Bruno.
So Bruno, do you know who is Hugo and who is Bruno?
I don't.
Okay, very good. All right, very good.
So we would like to talk a little bit about this project, this ongoing project that started in 2022 when the city of our university, which is Esch-sur-Alzette in Luxembourg, became European Capital of Culture. So we wanted to be part of the project, and we integrated a collaborative project which was called The Sound of Data. It was a sonification project, and our contribution was to gather thousands of drawings on iPads given by people from Luxembourg and all around the world. And then with these drawings, we collaborated with music composers, 3 of them, to extract data out of this big data set, and the composer took the data and sonify them and do some composition with them. And then at the end of the year, there was a large concert in the main rock scene in Luxembourg with people dancing on the compositions. So what you can see here is some images of the harvesting of this data, and you can see in particular that we had a very specific iPad stand to collect the drawings. So you can see exactly what you are seeing right now on the iPad. So you do a drawing, and then in a few seconds, the areas defined by the drawings were colored by some mathematical principle that is not explained when you do the experiment, but you can try to guess it.
So should we see some examples of some of these drawings?
I think we have a video in between.
Ah, perfect. Very good.
So this was in Dubai, in the World Expo, because we also went there to gather some drawings. There is sound if you...
No, I specifically said that there would be no sound.
Because we can hear you speaking in the background.
But just the sound that Bruno was hoping for was this woman who said, "Oh my God," when the colors appeared. That was the tidbit of sound that was useful for this. So here are some examples of drawings that we collected. So we collected in our initial harvest, we collected roughly 20,000 drawings. And here are some. So some people did abstract pieces. Some people did more figurative pieces. There are a lot of horses. People like to draw horses, which is sort of the archetype of a horse. And then there's, there's all sorts of things. I don't remember which drawings I put here, so I mean, the rest of the talk we're just gonna peruse the 20,000 drawings, and we will be done by sometime, maybe. And we're gonna go to, see, lots of horses. Very good. And so maybe one thing that you're wondering is the colors, and some of you see colors that appear. Bruno, do you want to maybe should we let the audience guess, or should we give them a hint? I don't know. What do you think?
For the interest of time, I think they need to guess. But we are happy to discuss it after that.
Very good. Okay. But indeed, the colors are not random. And you will see this on the iPad if it gets to you at one point when you're asked to do drawings. See, the colors are not random. And the point that the reason that we're talking about this as well is that this experience was so interesting to us that we decided to do it again, and sort of bigger and better. And this is exactly the exhibit Lifelines that you see that you can see at the current Shapes exhibition. And this is a nice one. Anyways, and now the design looks slightly different. So we've changed the design. Here are some examples with the current setup. So you can also do abstract, or you can do something more concrete. The colors are slightly different, and this time you can choose the colors. So this is one of the things that we improved on the new version. Is before you couldn't play around with the colors. Oh, this is a nice occasion to thank the EPFL Pavilions for hosting us and for letting us do this project in this particular thing. And one of the reasons that we started harvesting this drawing was an idea that we had together with Bruno of trying to. So we're of course mathematicians, right? We're not artists, but we thought that it would be nice to gather to get the pulse of collective creativity. And one way to invite people to use their own creativity and to bring it in. And then, of course, because you can take the mathematicians out of mathematics, but you can't take the mathematics out of a mathematician, once we have all of this, we want to study all the data and all the geometric information that was given to us. And so we started doing things like take the average of all the drawings. And so this is the average drawing from the first 20,000 drawings that we recollected. And our ongoing joke with Bruno was that this is because this requires a lot of work to go into it. This requires resources. We had to hire programmers, and actually on the Lifelines we have the chance of having Reina, who is one of the programmers on the current version of Lifelines, who is here. And this is very important. And so we put all these resources, and we were sort of saying that this would be the most expensive project to ever come up with the fact that the average drawing is going to be a straight line going across, right? And in fact, luckily for us, it's not. It's not. So this is what the average drawings looks like. And it's one thing that you notice in the average drawing is that people, when they draw from left to right, have a tendency of going up. Right? And this is something you can observe. So sort of the beginning of this average line is something that goes up, which is sort of interesting. And then you see something that's sort of more troubling, and it looks like the image is maybe pixelated. So let me zoom in just a little bit. And this is sort of what you see. This is sort of this line that becomes more and more random, and there's sort of I think there's sort of a deep reason for this, and one of the things is, and this is, we've been talking about this a little bit, when you do a drawing from a mathematical point of view, you're sampling, you're looking at a possible sample in what is essentially an infinite dimensional set. And when you have something, if you sample something in an infinite dimensional set, it's difficult to talk about randomness in an infinite dimensional set because there's no obvious notion of a finite measure on which you can do probability theory. And so what can you do, however, when you sample in something that's this large? You can do something that's slightly different, which is to say locally, if you look at the drawing and if it moves randomly in different ways, if you just keep changing your mind whenever you do the drawing and you keep going, then you have this sort of, you can do a local random drawing. And this is the mathematical notion of Brownian, this is Brownian motion. And so what you sort of see here in this drawing is, I think, I mean, it's sort of, this is like a working model, this is sort of the apparition of Brownian motion when you sample enough drawings, which is sort of an interesting mathematical phenomenon. But let me just show you some of the things we did with this.
Yeah, so this one, because you can't hear the music, but these were visualizations that we use for the concert, and so this is a visualization of an experiment. You don't want to put the music here?
I felt
okay.
like Ryan
okay, right.
felt like the sound was, so I sort of, no sound.
So because the idea was we let people draw under the influence of music. So one of the composers gave us some pieces of music, and we asked people to draw on the pieces of music. And then the composer took the drawing and he recomposed another composition on the drawing. And so this was an illustration of the visualization of the drawings without the music.
Exactly. Bruno, do you want to comment on this? This is...
Yeah, so yes. Maybe I need to wait. So yeah, okay. So this is a visualization of. So we structured the drawings by trying to define a distance between them. And for the mathematicians here, we approximate the Fréchet distance between the curves. And so we had a big space of drawings, structure space of drawings with an approximation of Fréchet distance. And so the artist selected two drawings he liked. And we choose some shortest path in this structured space. And what you've seen is an exploration of one of such a shortest path.
So again, this is sort of this notion that was hinted at before by Mark, is this notion of proximity between drawings, that you want to, and this is something we do a lot in geometry, you want to be able to measure the distance or measure the similarity between shapes. And you can do the same thing for drawings, and this is one of the ways in which we're using these sort of mathematical notions to explore this space of human creativity.
Yeah, so maybe some observations that we made, because we went a lot in front of people asking for drawings, and we made the following observation after a few hours. If you ask people to do math for you, they will say no. If you ask people to do art or give you a drawing, they will say no. But if you combine both, please, could you, or are you interested in participating in a collaborative art project using math? Then suddenly they are okay with it and very enthusiastic. So combining art and math helps engaging people.
And so the other thing, of course, is that the drawings are very culture dependent. I mean, this is not surprising, but we were wondering whether we had any sort of mathematical way of being able to identify, like, if you look at the different averages from different places where we took the drawings, like whether we were able to tell whether that's the average from one place to another. But it's more universal in the average than what maybe we would have expected. But definitely, when you look through the drawings coming from different places, there's definitely a difference between where we. For instance, if you take drawings in a high school in France, then you might imagine some of the drawings you get.
So one of the sources of the idea we had originally was, if you look at abstract art, abstract paintings, they kind of reach a universal balance with very few geometrical ingredients, archetypes. And so we wanted to question this universality. And it turns out that it reflects in some way in the experience of people, because drawing is really something that appeals to everyone. If you are a kid or an adult or an older adult, you like drawing. And so it's really an intergenerational experiment. And also you can see families coming to do the activity, and they all do it from 7 to 77.
Good. Maybe just the last quick observation is that the fact that you have this constraint that you have to draw from left to right, you can think of this as, I mean, we get the question a lot, why don't you let people draw in other ways? But this is something nice when you actually give people constraints. This gives at least a clear goal of something to do. There we go. So Bruno, what should we do with these drawings?
This is an open question.
Right.
So, well, we have a huge data set of drawings that we just started to harvest. We've structured it a bit with an average. Yeah, but so one question that you already mentioned is this cultural signature. Is there a way to recognize where a drawing comes from? This is an example, but we can also go to mathematical projects. I mean, more connected to mathematics.
Yeah, so we have lots of research sort of projects associated to this. But I mean, I think we should also think of this just as an open idea, is that we don't know yet what we should do with all these drawings, and we're of course open to suggestions. One of the things that we do plan on doing is we've done this experience once before, is to have people do drawings under, for instance, musical constraints, meaning that they have to listen to a certain piece of music while they do the drawing. And this is something we've already observed, which is sort of a very interesting point. And maybe the last point is this question is, can human mediation be replaced in these activities? Because even though it's very difficult to get people to do things, and this is something I think we'll talk about probably more in the panel. But when you want to explain things about math, and I suppose to some extent it must be true also with art, is that you sort of want people to. Art, of course, makes maybe a much better spectator sport than math. Watching somebody do mathematics is probably the worst possible thing you can imagine as a public activity. But in any case, getting people to do things is really paramount to success. So maybe we can end with this here, and just some pictures here of the current harvest, ongoing harvest at the pavilion. Thank you very much.